Okay, I'm doing the screen sharing. Please confirm if my screen is visible as well. No? Sometimes what happens, I start explaining without even sharing the screen. No one would bother. Okay then. So where were we in the yesterday's class? So if you remember, in the yesterday's session, we were discussing about the robust. Why Java is robust programming language? Yes or no? What is robust? Robust means when something is strong and healthy. You can it is a direct dictionary meaning. Okay, if you want to apply that meaning to the Java programming language, if you want to give the justification, there are some kind of attacks. For example, in the real time there are attacks like DDoS attacks, DOS attacks, which we have discussed yesterday, right? So these attacks usually they bring down the website so that the actual purpose of the website would not be used effectively. So DDoS attacks, there are legitimate. It happens legitimately. For example, if you are watching your what we call it as the university results, okay, most of the time it happens with the university results. So those are the legitimate. That is not deliberate. Sometimes what happens? Sometimes the hackers they perform DDoS attacks on the government websites to bring down the websites so that the actual purpose of the website could not be used effectively, right? So it will spoil the reputation of the website, it will spoil the reputation of the government. Okay, in such cases what they usually do, they usually avoid this by using what? By using the captchas, right? Captchas will ensure that the robotic activities, autobots cannot place multiple requests for a particular resources in the website frequently, sequentially. That's why there are checks like captcha checks, right? This captcha checks is the first level of protection for this kind of DDoS attacks or DOS attacks, right? So when you come to Java, what Java is going to, what kind of security measures has been taken by Java with this DDoS attacks and DOS attacks? If you ask me, Java has many internal APIs to deal with these attacks. That's why Java is called as what? The robust programming language. You cannot break down Java like very easily. Okay, breaking down the Java program in the runtime is very, very difficult. That's why it is called as what? The robust programming language. This is one of the reasons. And what are the other reasons? Okay, the other reasons are like, it uses garbage collector mechanism. So you got to know what is a garbage collector. Simply keep in mind, when I say garbage collector, it is not actually collecting the garbage. It is actually collecting the unused memory areas. Okay, as soon as the execution is completed, the memory that is occupied has to be released so that the next application can use those memory areas effectively. If it is not releasing those memory areas, what happens? Obviously, your RAM gets run out of memory, isn't it? If your RAM is getting run out of memory, it means the memory usage is more. If any application is utilizing more memory, okay, there is a problem, there is a performance issue. Okay, then and there the memory needs to be cleared. Okay, application has used your RAM space. After using, what it has to do? The memory that has been used needs to be cleared. Who is going to take care of that? Programmer? No, Java is going to take care of that. Java says, hey programmer, don't worry about the memory, you worry about the memory allocation. I will take care of the memory deallocation. That is called as garbage collector mechanism. So it is destroy the unused object or the object that needs to be released. I mean the memory that needs to be released once the application is once the execution of the application is completed successfully. This is one of the future to say that Java is the robust programming language. What is the third feature? It internally handles what? Exceptions with the exceptional handling mechanism. We have discussed these things effectively yesterday. What is an exception actually? Let us say that this is a front end. Okay, this is your system. There is an application. The application says, hey buddy, give me two numbers. Okay, I will give you the summation. Okay, you are entering not summation. I will divide those two numbers. You are entering 10. First number is 10, second number is 0. Right, this gets connected to the backend. First end gets mapped to the Java. Java is the backend. Right? First numerical value gets mapped to this variable A. Second numerical value will get mapped to this numerical. How it is getting mapped? Forget about this. Just imagine these things. Visualize these things. Okay. What you are supposed to do? You are supposed to do what? the division of two numbers. Okay, the moment your Java program performs a division, it encounters an error in the runtime. 10 divided by 0. You cannot expect. Okay, it is going to be like what is this 10 divided by 0? Infinity. Okay, it cannot calculate the value actually. So the program is going to get stuck, and the end user will not able to move forward. I mean, the system is going to stuck on the same page. He will not get answer. The answer will never get displayed over this box. Okay, the program remains stuck forever unless and until he retries this website and gives a different value. How you convey this message to the end user? Okay, there is a concept called exception handling. Okay, you use the try block. Okay, if there is any problematic statement, that problematic statement will be given the try block. Okay, if it encounters the 10 divided by 0 error, okay, a kind of exception, if it encounters an exception, that exception will be caught, okay, by using the catch block. Don't worry about this try and catch. This is the exception handling mechanism, right? You write a statement here. You can write any statement, a meaningful message. That meaningful message will get displayed in the console. So this is how you handle the exception in the runtime. This is also one of the reasons why Java is the robust programming language, because in the runtime it is very difficult to be broken. Right? What is the fourth point? What was the fourth point that we have discussed? As it is a platform independent, it is called as robust programming. No explanation is required for this. We have been discussing about this platform independency concept for a long period of time. Yes or no? Right? So having said this, okay, now if you go back and see, and we have completed almost 8 features, 8 buzzwords. Okay. Today we will understand why it is high in performance, why Java is considered as the high performance programming language. Okay, why it is considered as a high performance programming language. We will understand this today. Okay, shall we proceed? What is 0 plus 0? Everyone? Type in the chat box. What is 0 plus 0? 0 itself. People are finding it very difficult to. Even type Jyoti. Why Jyoti is not responding? Revati is not responding. Teja is not responding. Monica has responded. Yeah, good. Okay, shall we proceed, guys? Okay, then everyone are active. Okay, everyone are active now. Okay, then high performance. Okay, so I will tell you something to understand high performance. Okay, so focus here. This is going to be very interesting. High performance. So the performance is high in Java. Usually, if you want to give this answer, if you want to present this answer to an interviewer, okay, what you would say that the performance is high in Java. That the performance is high in Java because of what? Because Java uses what? A HOTSPOT JVM. HOTSPOT JVM. Okay. The interviewer is very clever than you. He would ask you with a follow-up question. What is an HOTSPOT JVM? Of course, okay. This is a rudimentary statement, right? Not very clear. So you would ask you what is an HOTSPOT JVM. You would say that the JVM, there is a JVM. Yeah, so there is a JVM. The JVM which contains the JVM which has JIT compiler. JIT compiler is called as HOTSPOT JVM. Okay. An interviewer would ask you once again, what is this JIT compiler, man? Okay. What is a JIT compiler? What is a JIT compiler? What you would say? Okay. JIT is an acronym for JIT stands for Just-in-Time Compiler. Interviewer would ask, can you explain me little bit further? Okay, if I tell you these 3 lines, you will not understand. Okay, you need to understand the internal picture. What is this HOTSPOT JVM and what is a JIT compiler? If you understand this too, then you will understand why Java is high in performance. Why then you will understand what Java is high in performance. Let me copy this and put it in the paintbrush. Okay, so why Java is high in performance? Theoretically, these 3 lines are enough to convince the interviewer. Enough more than 3 lines. These 3 lines are more than, but we need to understand what are these 3 lines What is the JIT compiler and what is this what HOTSPOT JVM? So no, let's understand one by one. Okay, so we know these things already, guys. So see, this is like whenever, for example, if I have a piece of code, okay, let us say that I am writing a piece of code. Stop doing this. Let me write a big code. So you write a piece of code. Let us say that the piece of code is a.java. Some .java file. Any file which contains Java code is called as what? Java file. I mean, the extension should be a.java, right? So what you usually do, this a.java needs to get compiled, right? Why we are compiling it? Because compiler will ensure that the code is error free. If any errors are there, you will get an intimation. Hey, there are some errors. Please correct that. If there are no errors, compiler will be happy to generate what? The dot class file. Sir, no. A.java file will get converted to a.class file, right? And after that, what happens? This dot class file needs to get executed. So this is an intermediate code or the bytecode. Okay, you need to send this dot class file to the JVM. Okay, JVM comes into the picture, right? You will have to send this dot class file to the JVM. JVM is coming to the picture. So when you say this is JVM, internally JVM has so many programs or else so many softwares that are working together to do what? To perform the memory allocation, to generate the main thread, and to load the classes. JVM is not just JVM. Internally, it has many parts. And one of the parts is what? The JIT compiler. One of the parts inside the JVM is called as what? JIT compiler. What is it? JIT compiler, just-in-time compiler. We'll understand what is just-in-time compiler. Now you can come to this question. Okay. Whenever if you see a JVM with JIT compiler, it is called as what? HOTSPOT JVM. Okay. So this is the JVM. This JVM has a compiler called JIT compiler. Now you can define this JVM. You can call this JVM as it's not an ordinary JVM. It is called as what? HOTSPOT JVM. Or like mobile hotspot, it's not like just like mobile hotspot. This is just a naming convention. HOTSPOT JVM. HOTSPOT JVM. Why it is HOTSPOT JVM? There is a JIT compiler in this JVM. It's called HOTSPOT JVM. These HOTSPOT JVMs are introduced in JDK 1.2 version. Before that, there is no concept of those JVMs are an ordinary JVMs, but exactly in JDK 1.2 version, the second version of Java. In the 1.2 version of Java, the HOTSPOT JVMs are introduced. Very simple. You have a JVM. If the JVM has JIT compiler, okay, then that JVM can be called as what? The HOTSPOT JVM, right? And after this, what happens? This is what we usually understand how the code is getting converted and executed, right? After that, the JVM will generate the native code, zeros and ones, right? So this native code will get interpreted by the main thread. This native code will get interpreted by the main thread, and the output gets executed. I mean, output gets produced or generated. Output will get the output. Will get the output. Okay, sir. We have know all these things. Why you are discussing this now once again? The question is how the .java file has been drafted. You get the output at any cost of time. You will get the output. This is how you are going to get the output. That is okay. But the question is how you have written the .java file. How the .java file has been drafted. Okay, I want to see what lines of code are there in .java file, so that your justification, my justification on top of JIT compiler is understandable, is explainable. Okay, to understand this, now you see, now we focus here. I have a piece of code again. So this time I'm taking the real code, guys. Focus here. The name of the code class is class A. Inside this class A, I am going to take a method called public static void main string array aux. Okay, one main method I have taken. After this main method, I am also going to take a user defined method. Don't worry about this main method and user defined method. Okay, we are just trying to understand the concept of JIT compiler. Okay, these methods are very easy to understand. So I have taken a method one. Okay, now let me divide this into two parts. Now you see. Okay, so this is where the class, the opening, the class opens. Okay, class closes. We know, right? Class is a blueprint, right? Inside this class, you have methods and you have properties. Okay, this is where the main method opens. Main method opens, right? And here the main method closes. Okay, this is user defined method. User defined method opens. User defined method closes. Now you see, now the interesting part here is, when you put something in double, the double forward slashes, they are just a comments. Okay, it means compiler is not going to consider this comment, right? So this is my piece of code, a very big code. Why it is very big code? For our understanding level, because since we are just started learning Java, for us it is a very big code. Let me place a comments here also. Okay. Good. Now you see, guys, let us imagine that there are about 10,000 lines of code inside the user defined method. When I say 10,000 lines of code, okay, just for the imagination, I am saying, okay, I have a method. So this is my method. This is my user defined method. I define this method. Inside this method, I have returned or I have drafted how many lines of code? 10,000 lines of code or 10,000 lines of instructions. Okay, this method is loaded with 10,000 lines of instructions, right? And I have a main method. Okay, so the moment I start this, right? I need to save this code as what? A.java, right? A.java. So let us assume that the code has been saved in the form of what? In the form of A.java. It has to go through the compilation. Compiler will come into the picture. What compiler will do? Compiler will convert this A.java into A.class file, right? Then this A.class file will be loaded to inside the JVM. Yes or no? So what JVM will do? JVM will create a main thread. JVM will do what? JVM will create a main thread. Okay. What this main thread will do? In thread, it always try to search for the main method. Main thread will always try to search for the what method? Main method. Okay. It will go to a.java. It will be searching for the main method. Okay. If it finds the main method, it is happy. So this is the main method. When you find something main, and if you find this prototype, okay, these are the main method. It will try to execute all the instructions inside the main method. Is there any instruction inside the main method? Main method is empty. Okay, so it gets into inside the main method. It will try to execute all the instructions inside the main method, but unfortunately there are no instructions inside the main method. It is empty. Okay, well, never mind. It will come back to the JVM. Okay, and it will destroy itself. That is actually now what I am doing here. I want to call this method what? I want to call this method what? I want to call what? I want to call this method one, right? So I want to call this method one from the main method. The method call is very simple. Okay, what is the method name? Method one. Okay, just type method one here. Method one. Okay, and place a semicolon. Give the method one and give this opening and closing bracket and just place it a semicolon. The moment you do this, again if you repeat the execution, okay, a.java compiler a.class main thread will be created. Main thread will get access to the main method, right? And this is the main method, and here it finds, okay, the programmer is trying to call the method one. The program is trying to do what? Call the method one. It will try to find the method one in the current class. Okay, method one is here. Okay, matching method one. Now control is just transferred from this method to this method. You are instructing, programmer is instructing from the main method to execute another method which is inside the same class. Are you able to follow? Method 1 has found the main thread has found the method 1. From here, the control will jump here. All instructions inside the method 1 will get executed. Now, what are the instructions? We don't know what are the instructions, but I said there are 10,000 instructions. Okay, now what is happening behind the scenes? Now, what is happening behind the scenes? Right? To execute each and every instruction. So, first instruction will read the line. What it will do? It will perform 3 operations. Read operation. Second one, interpret operation. Third one, execute operation. Each and every line. For first line, okay, the main thread has to perform these 3 operations: read, interpret, execute. Again, for the second line, perform these 3 operations: read, interpret, execute. Again, for the third line, it has to perform this read, interpret. Again, for all the 10,000 lines, it has to perform what? Read, interpret, execute operation. Execute operation. Okay, good. This is the job of the main thread. And main thread will, as soon as if it wants to execute each and every line, it has to do these 3 operations, right? After completing all the 10,000 instructions, it has to go back to the place where it was transferred, where the control was transferred, from where the control was transferred. After completing all this, the control was transferred from year to year, right? It has to go back to the same place, and there are no more instruction after this method 1, so it will go back to JVM and it will be destroyed. Now let me tell one more thing. Okay, what if I call this method for the second time? I'm calling this method for the second time. I'm same method for the second time. I also want to call the method for the third time. Method 1. I want to call the same method for the fourth time. Okay. And I also want to call the method for the fifth time. How many method calls are there? 5 method calls. Right? Let us start the execution from the beginning. A.java. Okay, this is how my code is. It has been saved with the .java extension. A is represented in the class name A.java. Fine. Okay, A.java needs to get compiled to check for errors. After the compilation, A.class file will be generated. Okay, this A.class file will be loaded inside the JVM. Okay, JVM will do what? JVM will create a main thread, empty. Okay, main thread will come with the picture. Okay, let us say that this is a control. The main thread will jump to the Java A class and it will try to find the main method. Keep finding the main method. Yes, main method is found. Okay, the main method is going to do what? I will main method says I will be happy to execute all the instructions inside the main method. What is the first instruction? A method call. Method 1 is there. It means main method will understand, okay, the programmer is trying to call a method 1. It will go back here. So it will try to find method 1. Method 1 is there. 10,000 instructions needs to get executed. Now focus here. 10,000 instructions need to get executed. Okay. Again, it will go back to the place where it was transferred. Second time again the same method. Now JVM. Now what will happen? Okay. JVM will start counting. JVM will start counting what? How many times the same method is getting. When same method is getting executed sequentially or many number of times, this HOTSPOT JVM is going to start counting. HOTSPOT JVM will start counting. Count number 1. Okay, method 1 is executed. Okay, each and every time method 1 is executed, read, interpret, execute operation is happening. 10,000 times the same read, interpret, execution, is happening. Okay, again control is going back. Now this is completed. Right? Now the second call, second call is what? Second instruction is what? Again M1 method is called. The same method is called. Again 10,000 times it has to go through read, interpret, execute. Now the count is what? Now the count is what? The count is 2. The count is 2. Second count. Okay. JVM will do nothing. JVM will do what? If the same method is getting executed over and over again, starts counting the executions. Okay. So second time also done. Right? And the third time. M1, again method 1. Control will go back. Again same method. Okay. It will mark the count as 3. Okay. It will mark the count as what? 3. Okay. So these HOTSPOT JVM are very clever enough. Okay. It will try to count how many times a particular method is called. If it is getting called over and over again, for the HOTSPOT JVM, there is a threshold. Okay, the threshold can be 2 or 3. The threshold can be 1. Sometimes, mostly it will be after 2 counts that threshold will start. It will start. Okay, third time also the method programmer is trying to call the same method. Okay, third time also the programmer is trying to call the same method. Okay, this point is called as what? The threshold point. What is this point? The threshold point. Focus here. This point is called as what? The threshold point. Threshold point. Why threshold point? JVM recognized that a pattern is being recognized by the JVM. Why this programmer is trying to call the same method over and over again? One time is okay, two times is okay, and he has started calling for the third time, acceptable, then it marks it as a threshold. Okay, the moment the programmer start calling the method for the fourth time, okay, the moment the programmer is trying to call the method for the fourth time, what the JIT compiler will do? What the JIT compiler will do? JIT compiler. Now the JIT compiler come into the picture. Just-in-time compiler come into the picture. It converts the total code into the native code. Okay, now the JIT compiler come into the picture when it after reaching the threshold, and again when the same method is being called for the fourth time after reaching the threshold, or after reaching the threshold again if the same method is being called. Okay, JIT compiler come into the picture. This is the JIT compiler, right? Okay, sir. This is the JIT compiler. Okay, it converts the total. It converts the total code. JIT compiler, it will converts the total code. This is the total code, isn't it? Converts the total code into a single native code. It is single native code. Single native code is what? Something like 101010. Single. I mean, it is understandable by the machine. Total code will be converted into a single native code. JIT compiler converts the total native code to the single, I mean total code into the single native. Converts the total code into the native code. So what is the advantage of doing this? Okay, when the moment you call this method after the threshold, right, total code gets converted to a native code. Okay, so when you call this method, same method for the fourth time, instead of doing read, repeat, execute operation, focus here. Now this time JVM does not need to do the read, interpret, execute for the 10,000 lines. Directly it will jump to the native code and it will process the execution. For example, if this read, interpret and execution operation takes 10,000 units of, for one line it is take 1 unit of time, for 10,000 lines it is taking 10,000 units of time. Units of time consuming, right? Every time read, interpret, execute. Okay, second time is also okay, another 10,000 units of time. Third time is also okay, another 10,000 units of time. Okay, threshold has been reached. If the method is called for the fourth time, it will not take 10,000 units of time. This time the native code is going to be only one line, only 1 unit of time. Only what? How many units of time? Only 1 unit of time it is going to take. Again, if you call this method for the fifth time, only 1 unit of time. Okay, time is drastically reduced. Are you able to follow? Time is what? Getting reduced drastically because of this JIT compiler. Because the JIT compiler, as soon as the JVM recognize the threshold, right, the JIT will come into the picture. It will convert the total code into a single native code, right, so that it can avoid doing what? Read, interpret, execute operation. Don't you think so? Because of this, okay, because of this, the time has been reduced. Because of this, the time is going to get reduced totally and the performance is going to get increased. When I talk about performance here, when the time is reduced drastically, right, when the performance is increased, can I say that this is high in performance? That is the reason why Java is high in performance. Okay, now these 3 points are enough for the interview room. The performance is high because it used a HOTSPOT Java. It uses a HOTSPOT JVM. and the JVM has, which has the JIT compiler is called as what? HOTSPOT JVM. JIT stand for this is enough for the interview room. They are asking you for this explanation that you can give. What explanation you can give? Then the same method is being called for several amount of time, number of times. Okay, each and every instructions inside the method has to go through read operation. Okay, what operation? It has to go through what? Okay, the read operation, the interpret operation, the execute operation. Read, interpret, execute. For each and every line, read, interpret, execute. Okay, if these read, interpret, execute, read, interpret, execute for 10,000 lines, it may take 10,000 units of time. If it is executing for the one time, okay. But again, you calling the same method. Again, it has to go to read, interpret, execute, read, interpret, execute, read, interpret, execute. Again, 10,000 units of time. For the third time, you are calling. Okay, again read, interpret, again 10,000 units of time. Now the JVM is clever enough to identify the pattern. What is the pattern? Oh, the same method is being called for the so that pattern is called as what? The threshold point. A threshold point. Once the threshold point is reached, what it does what? It activates the JIT compiler. Then the JIT compiler will convert this total code into a single byte code. Single native code. Okay, and again, if you call this method for the fourth time, okay, if the method is being called for the fourth time, instead of performing all this read, interpret, execute operation, it is just will execute this byte native code only one time. Actually, when I was living in Bangalore, right? So every day, I visit a grocery store. Grocery store. Every day we visit the grocery store. Okay, I'll tell you the purpose. So I'm living in a single. I was living in a single bedroom flat. Okay, I do night shifts in the daytime. I come to my room. As soon as I come to my room, I clean up everything, and I visit this particular grocery store. Name of this grocery store is what? The Sakti store. So every morning I go there. Okay, I ask the salesperson comes. What do you want? I will ask him. I want Maggie. Want what? Maggie. Okay. Okay. He gives me Maggie. I cook Maggie. Okay. I go to sleep. Right. In the afternoon I order some food, and in the night I eat outside. Next day, first day is okay. Next day I go there. He would ask me what you want. I say I want Maggie only. He would give. Third time I go there, I would ask what you want. Maggie. He would give. Fourth time I go him, even without asking, he will place the Maggie. He used to place the Maggie on the desk. Okay, don't you think that he has observed the pattern? This person is coming here only for the Maggie. He's not eating anything apart from Maggie. He has observed that pattern, and he is clever enough to identify my requirements in advance because of the pattern. Because of the pattern that I have created. Maggie, I'm buying Maggie every day. 3 days I have bought Maggie. 3 days the Maggie I have bought. So he is clever enough to identify pattern has been observed. Same thing. Even JVM also does the same thing. The pattern is observed by the JVM in all occasions, in all cases. How it is observing, that are internal things. But why is high in performance? That is the question. Hope my explanation is giving you some justification. Are able to follow? Type as in the chat box if it is good, or we need to proceed further, or you want me to explain again. Are we good? Yes or no? Come on. Everyone type, guys. How long it will take? Type yes, guys. Revati, Monica, Tika, and Teja has typed. Okay. Jyoti. Okay then. So let us move to the next topic. So once these things are very clear, programming part is going to be very, very interesting. Okay. You will get goosebumps the way I'm explaining you. Next, so we have completed this. We have completed what? Now you got some picture about why it is high in performance. Okay, now we will understand why it is dynamic programming language. Why Java is called as what? The dynamic programming language. Right? Why Java is called as dynamic programming language. right? So there are 2 points, very simple. Memory will be allocated. Memory will be allocated on demand. It means you're saying memory will be allocated on demand. What does it really mean? The second question, memory will be, sorry, not memory, dot class files will be loaded on demand. Dot class files will be loaded on demand. Memory will be allocated on demand. Both are one another. Both are same actually. We will understand this. Why it is called dynamic. Let me put this in the paint brush. So these are the things that we can explain to the interviewer why Java is dynamic. Okay, you will be satisfied if you say these 2 points. But if he asks you more, you should be in a position enough to explain him, right? I will give you the things. Dynamic means memory will be allocated on demand. Dot class files will be loaded on demand. Now focus here, guys. Now let us understand the internal things of the programming language. How the compilation is happening. At the same time, I will help you to understand. Let's say that I have a piece of Java code. I'm going to write a class. Okay, name of the class is class A. Inside this class A, I am writing a main method, public static void main string array arguments. We focus here. Okay, don't worry what is class, what is this method. Class is a blueprint for now. Class is a blueprint. Class has a name. Okay, I'm keeping the name as A. Okay, you should always place a main method. What is a main method? It is a method where the execution starts. Okay, this is how the main method is going to be. You will understand each and everything, what is public, what is static, what is void in the future topic. For now, try to understand why it is dynamic. Okay, this is how the main method. Just by heart for now. Public static void main string something, opening and closing simple brackets args. Right? This is how the main method prototype should be in lower cases. This is in the upper case. Okay, I'm placing one instruction. To keep the instruction simple, I'm placing the instruction like system.out.println. Right, inside this, okay, just I am placing a statement testing to check whether the main method is executing this or. Okay, now where did I write this code? I have written this code in the notepad. Okay, let me open the directory. Okay, let me delete all the existing files. Okay, so I want to save this code inside this directory, D directory, or in the D folder, in the D directory, the Java 2 folder. Right, very simple. Okay, this is my code. Okay, this is my Java code. So I have written my piece of Java code in by using what? By using the notepad. A piece of Java code has been written by using the notepad. Okay, this is my notepad. Okay, so I want to save this, right? So I want to save this. Okay, I'm saving this. It has been saved with a.java extension. If you see, name of the file is A, right? Java file. It has been saved with a.java extension. In which directory? In the D directory in Java 2 folder. There is a folder called Java 2. Right? The name of the file is a.java. If I open this again, it will come a.java. You see, a.java. Right? So I have just saved this so that my operating system will understand that this is representing a Java code, a.java. Focus here, very important. After this, I want to perform the compilation. I want to perform what? I want to activate the compiler. I want to perform the compilation. I want to activate the compiler. Right? To activate this compiler, right? So I'm going to use what? I'm going to use the command prompt. Okay, this command prompt is going to communicate with the Java programming language, Java software, to perform the compilation and the execution. Don't worry how this command prompt operates. For now, try to understand how I am activating the compiler. In the future classes, we will understand more about this. Okay, I want to choose the directory where my Java file has been saved. Okay, so I'm changing the directory to D. Inside D directory, I have a folder called Java 2. Inside the D directory, I have a folder called Java 2. Inside this, I have a Java file called a.java. I'm choosing the directory here. Right? I want to activate the compiler. To activate the compiler, the command is very simple. Okay, Java C means Java compiler space. What is the name of the Java file? A.java. Okay, the moment you press enter button, okay, what happens behind the scenes? This compiler gets activated. Because of what command? Java C space a.java. Okay, Java is C is a command to activate the compiler, and it performs the compilation on top of which file? A.java file. So what will happen behind the scenes? Okay, compiler will check all the lines one by one. Okay, if there are no errors inside this Java file, it will create what? It will create a file called what? The dot class file. It will create a file called what? The dot class file. Okay, what is the name? A dot class file. How do we know the dot class file has been created? If you open that same directory, okay, you will be able to see a class file here. You're able to see. Previously, it was not there. Okay. So the first file, okay, the first file is Java file, which is what? A.java. Okay, after you activating the compiler, you perform the compilation, a file has been created, a new file has been produced. Okay, what is that file? Class file. A.class file. A.class file is A.java file. Where is that A.class file? In the same directory. Where is it? In the same directory. If you open this, you will not understand anything. This is how the dot class file looks like. The intermediate code. Dot class file. This is dot java file. Dot java file has been converted to dot class file. Okay, this conversion will happen only if the dot java file has no errors. Are able to follow? Right? After this, what happens? Okay, this is the a dot class file, right? So this a dot class file has to get loaded inside the JVM. It has to get loaded inside the JVM. JVM is here. JVM is there, right? So you need to load this a dot class file inside this JVM. For that, there is a command. JVM. Okay, for that, there is a command. What is that command? Very simple. Go to the command prompt. Go to the command prompt. Just type Java space the class name. Java space A. A is the class name. Okay. Now this is the command. Okay. Command is what? To load this dot class file to the JVM, you need to give a command to do that loading. What is that? Java. Java means you are talking to Java space. You are saying A. A is the class name. The moment you do this, okay, this dot class file will get loaded inside the JVM. Will get loaded inside the JVM. As soon as this is loaded, a main thread gets created. Right? This main thread gets access to what? Access to the main method. Right? All the instructions inside the main method get executed. But there is only one instruction, which is what? Testing. So in the output, okay, you get what? You get something in the console. What is it? Testing. Testing will be displayed in the console. So what is displayed in the console? Testing. After having this displayed, okay, it goes back. It goes black, and it gets destroyed. Okay, so far so good. We know this all the things, but there is one statement. One statement I need to understand. Okay, I need to understand about something called static blocks. Okay, static blocks. Okay, sir. This thing is very important. In future, I will explain you each and everything in detail. For now, we are trying to understand why it is dynamic. Okay, to understand this dynamic programming language, you need to understand the static blocks also. Okay, these blocks are recognized and executed at the time of loading the bytecode or the dot class file to the memory. First point. Second point is static blocks or static blocks are executed first even before the main method. That's it. Why we need to study about static block? We will understand about the static block to understand about the dynamic programming language or to understand about these 2 points. Okay, now I'm doing some corrections in the program, small changes in the program. Okay, so where is our program? Where is our program? So this is our Java program. Right now, what I want to do, I have just mentioned about a static block. Static block means very simple. What is a block? Block is nothing but a opening bracket and a closing bracket is called as a block. This is called as a block. Open when you open something and when you close something, you call it as what? Block. And if you just put static keyword, it becomes static block. So what is a static block? In a Java class, if you open and close a block, that is going to be an ordinary block. The moment you keep the static keyword, the moment you place the static keyword before the block, before opening the block, that becomes static block. And even inside the static block, you can place n number of instructions. Yeah, well, I simply want to place only one instruction. Okay, simply saying that, hey, this is my static block. What is it? Hey, this is my static. Okay. Now, if I ask you a question, what are the items that is there in class A? What are the items that is there in the class A? What you can say, sir, there is one item which is called main method. Okay, inside this main method, one instruction is there, and there is another item which you have just introduced, which is called what? Static block. Inside the static block, what? There is another instruction. Okay, now my question, if I now focus here, now this is very important. Now this is very important. Now you understand the execution flow. Okay, now you understand this. Okay, now go back to this. Go back to this statement which I have just described. What are static blocks? These blocks are recognized and executed at the time of loading the bytecode or the dot class file to the memory. They are executed first even before the main method. Okay, now let me help you with the control flow. Okay, we will use this place. Okay, let me copy the code. Okay, let me copy the same code. Let me delete the things that is already there inside this folder. If you get locked out of the meeting room, please rejoin. This is going to give you some goosebumps. Okay, the control flow is going to be very interesting. If you get locked out of the meeting room, please rejoin. Now you see, guys, I want to repeat the same thing. Okay, so this is, now if you look at the folder is empty. The folder is empty. Okay, I am giving what? This is my ordinary file. Okay, the moment I store this file with let us see, file save as, okay, in the Java 2 folder. Okay, the ordinary file needs to be converted to the Java file. So a.java. Okay, successfully the file has been saved as what? A.java. Now the computer is clever enough to recognize this as a Java file. It says Java file. See, the type is what? Java file. Okay, what I just did, I will do the same thing in the paintbrush. Okay, I have created a program, a Java program. Okay, and my code. So this is my code. Okay. I have just saved this code by using the notepad with .java extension. So a.java. A is the class name. A is representing the class name a.java. If I ask you how many components are there, how many things are there inside this class, you would say there is a main method and there is a static block. So this is the static block, and there is also a main method. Okay, after this I want to perform the compilation. I want to activate the compiler. Okay, what is the command to activate the compiler? Okay, this is the compiler. What is the command to activate this compiler? Very simple, javac space a file name a.java. At the moment you do this, the compiler gets activated. Okay, you are going to take the help of command prompt to do what? To perform the compiler activation, right? Now you focus here. If you go back and see the folder structure, only Java file is there. Okay. After the successful compilation, javac space a.java is the command to activate the compiler. The compiler will perform the compilation. It will check each and every line of the code. If the code is error free, it is going to generate .class file. Okay, something has happened. Okay, this is just blinking. If there are any errors, it is going to show errors. Since there are no errors, it is just blinking. What happened behind the scenes? If you see, now you can see the class file here. Previously there was only Java file. Now you can see class file, which means .class file has been generated successfully. Okay. Compiler is activated. It has checked each and every piece of code. Then what it said? I have generated a .class file for you. Okay, what is the name of the .class file? Again, a.class file. Okay, now we need to send this .class file to what? You need to send this .class file to what? JVM. To whom we need to send this? JVM. Let me tell you something. If we have only one class, in your program, one .class file will be generated. If you have 10 classes, 10 .class files will be generated. If you have 20 classes, 20 .class file will be generated. Since you have only one class, only one dot one not Java, it is .class. Right? How we are going to send this .class file to the JVM? This is JVM. So what is the command? Again I am saying, don't worry about this command prompt operations. I will explain you. I will give you the complete notes. Try to understand this. Okay. What is the command? Java space a. For saying, hey Java, try to take the a.class file. Hey Java, please take a.class file. Shall we give that command here? Java space a. Now you see what will happen. If I just click on enter button, don't see the output. Okay, I just click on enter button. Okay, what happens? What will happen? .class file will be loaded to JVM. .class file will be loaded to JVM. It will be loaded. You see, now we focus here. At the time of loading the .class file to the JVM, the time of loading, the moment it is loading, okay, during this time, what happens? If there are any static block, focus here. Let me repeat this. At the time of loading the .class file to the JVM, static blocks are recognized and executed first. Okay, static blocks in the class A. First priority will be given to the static blocks. They are recognized and executed at the time of loading the .class file. I can also say that the particular .class file is successfully loaded the moment the static blocks are executed. Both are same. I can also have the confirmation that the a.class file is loaded inside the JVM when the static block of a.class file gets executed. Let me repeat it once again. At the time of loading the .class file, what are the instructions inside the static block will get executed? What is the one? There is only one instruction. Yes or no? There is the only one instruction. Hey, this is my static block. This instruction will get executed. Why? At the time of loading the .class file to the memory, priority will be given to the static block. That the instructions inside the static block will get executed. Hey, this is my static block. Okay, first priority will be given to the static block. I can also say that because of the static block execution, it is a proof that a.class file has been loaded because of this output. I can also have a conclusion that my .class file has been successfully loaded inside the JVM because I can see that this specific static block is executed. Both are same. It is also a proof, and it is also like At the time of loading the .class file to the JVM, static blocks are recognized and executed. Okay, there is only one static block, only one instruction is there, that will get executed. Then the main thread gets created. Then the JVM creates what? Then the JVM creates the thread called the main thread. Okay, this main thread gets access only to the main method. It will not get access to static block and all. Static block execution is already completed. Okay, main method is there. What is instructions? The main instructions inside the main method. Testing. Testing is instructions inside the main method. Right? That is get executed, and after the execution, it goes back, and the main thread gets destroyed. Right? If you see the output, see, hey, this is my static block testing. If you see the coding, okay, first priority is given to the static block because at the time of loading, what is the explanation? If you go back to my explanation, you would see static blocks are recognized executed at the time of loading the bytecode or the .class files to the memory. Static blocks are executed first even before the main method execution. Hope you're able to give the justification. What it has to do with this? What it has to do with this? .class file will be loaded on demand. To understand this, I will give you one more program, the last program, okay, which will clear. If you have any doubts, focus on this program. All your doubts will be clarified. I think it's time that the Teams app will knock you all out. Please rejoin, okay? Please don't be like once it is knocked out, don't stay idle and go away. Please rejoin. These things are very important for the interview room. Trust me, people have cleared their rounds because of my explanation. Please rejoin, guys. My third program. Okay. I want to add another class. Same program I am keeping. Okay. I have class A and I am taking another class B. You can take any number of classes in a particular file. Okay. I have a class A and I have class B. Inside this class B, I am taking a static block. What is a static block? Any block opening and closing with a static keyword is called a static block. As simple as that. Okay, now what I am doing, I am placing one instruction inside this class B. Hey, this is my static block of class B. And let us say that this is my static block of class A. And don't worry, I am not teaching you Java programs. I am teaching you about the why it is dynamic. Now we will understand why it is dynamic. Okay, now two classes are there. Are we connected, guys? What is 1 plus 1? Are you sleeping or are you with me? 1 plus 1, guys. Please help me with 1 plus 1. Thank you so much for rejoining. Yes, 1 plus 1 is 2. That's correct. Only 2 people have answered. Okay, anyhow, since you have rejoined, I will assume that everyone are listening. Now let us go back to this. So what I was saying, okay, please quickly confirm if my screen is visible and if my voice is audible. Come on, someone confirm. Oh, good. See, now I want to take two classes. If I ask you, if I ask you, I'm a faculty, you are my students, right? If I ask you, explain me about this file, you would say in this file I have two classes. One is class A, second one is class B, and also you would say the main method is placed inside the class A. The main method is placed inside the class A. Always remember, guys, whenever you place the main method is what? The method that comes with the main. This is the main method. Whenever you place the main method inside a class, that class will become the main class. So now class A is the main class because it has main method. Okay. Inside my main class, I have also a static block, and inside the other class, I have also a static block. Right now I want to save this. Okay, let me delete all this. Okay. one more option. Now you focus here. Okay, so this is my piece of Java code which has two classes. Okay, I want to save this. Okay, file, save as. Okay, how would you save this? There are two classes. Which class name I need to take first? That should be the first question. What I would say, any class which has the main method. Okay, use that class name to save the file. Okay, the class A as the main method, so we're going to use what? A.java. Even though you have 100 classes, the class which has main method, you use that as the class name, A.java, because A class as the main method. Okay, it has been saved successfully. What is the proof? Now you can see it has been saved as Java file. Okay, now we will perform the same things. Okay, now your attention is much required here. Okay, I want to take a new paintbrush. Downloads desktop. That's to is class number 14 or class 13 now. Class 14, right? Okay, now we focus here, guys. Okay, very big class. We have a big class. Okay, so this is our class. So how did I save this class? I have used what? A.java. Okay, A.java. Focus here. What is the proof? If you go to the folder, you can see Java file, which is what? A.java. A Java file means A.java. Right? Now what I want to do? Okay, code is I want to perform the compilation. For the compilation, what I have to do? I have to activate the compiler. How I can activate the compiler? To activate the compiler, I need to use a command in the command prompt. Okay, is what? Javac. Java means Javac is a compiler, Java compiler. Okay, just compile A.java file. Okay, this command I need to use in the command prompt. Go to the command prompt. Okay, just to do what? Javac space A.java. Okay, so it is blinking means it has been compiled successfully. Now you need to understand one thing. Okay, after the successful compilation, okay, you have activated the compiler. Okay, and the compiler has what? It has done all the compilation checks. Everything it has been, it has performed the compilation check, and it is going to generate .class files. The question is, how many .class file will be generated? Question is what? How many .class files are going to get generated this time? Okay, how many classes are there usually? You have class A, you have class B, you have. Literally, technically, there will be two .class files. How many .class files? Two .class files. One is what? A.java. Second Indian is what? B.java. Okay, this B.class, B.class, A.class and B.class. Okay, these .class files are directly proportional to number of classes in the particular. That is the proof that two .class files are generated. Go back and see. Are you able to see two class files are there? Okay. You are able to see this. Okay. Okay. So this is the file that you have saved as Java file. After the successful compilation, you see what? Two class files. One is A.class and B.class. Okay, now the question is, you need to perform the execution. You need to perform what? To perform the execution. So here it is very important. Okay, to perform the execution, you need to what? You need to send the .class file to the JVM. You need to send the .class file to the JVM. Yes or no? You will have to send the .class file to the JVM. Right? Now what you are going to do? See, to do that, there is a command called Java space the class that you want to send. If you send Java space A, you send Java space A, means A.class file will be sent. Okay, only you can use only one command. Okay, why I am using A? Because the main method is there inside the class A. The main method is inside the class A. So you need to use what? Java space A. Okay, the moment you do this, see, where is this command prompt? The moment you do this Java space A, I don't want to show you the output. Okay, what happens? A.class file will be loaded. A.class file will be loaded inside the JVM. A dot class file will be loaded inside the JVM. At the time of loading, it will check, is there any static block inside the class A? Is there any static block inside the class A? Is there any static block? Yes, there is a static block. Okay, here is a static block. Okay, the static block will get recognized and executed at the time of loading the dot class file to the memory. Dot class file is being loaded at the time of this operation. At the time of this operation, static block content will get executed. What is the content inside static block? Hey, this is my static block of class A. After this, what happens? Main thread will get created, right? After this, what happens? Main thread will get created. Then main thread will get access to the main method. And all the instructions inside the main method will get executed. All instructions means there is only one instruction, testing. Testing will get executed. Okay, in the output, testing will come. Okay, and it goes back. And the main thread gets what? Main thread gets destroyed. It goes back and main thread gets destroyed. But now if you see here, okay, let me undo this. Okay, now if you see here, there is also a class B. Class B is not loaded inside the JVM. If the class B is loaded inside the JVM, definitely b.class file has to get loaded. But this is the proof, because if you look at the output, only you can see this is my static block of class A, which means only a.class file has been loaded. Or else you can also see this in the console. This is my static block of class B. Why this is not loaded? Because you haven't called this class B. Class B is generated, but it is not called. Let me make a small change in the program. This is my program. Okay. Now what I am doing, okay, inside the main method, I am creating an object for class B. Obj equal to new. Okay, I have placed a new instruction. Now focus here. I have added a new line. Okay, focus here. After this, there is a line called obj equal to new b. Okay, I have just added this line obj equal to new b. After testing line, I have added this line in the main method. Okay, I want to repeat this. Okay, I have performed the compilation and two dot class files are created. Right, and during the execution, you are calling what? Java space here, which means main dot class file will be loaded inside the JVM. At the time of loading this main dot class file, all the static blocks are recognized and executed at the time of loading the dot class file. Static blocks gets recognized. Static block of class A will get recognized. So what is the static block of class A? There is only one static block of class A. Right? So what is the execution? Okay. Okay, this is my static block of class A. Okay, it is recognized successfully and it is executed. After this, what happens? It will create the main method, the main thread. Okay, this main thread gets access to the main method. Now focus here. Main thread gets access to the main method. Right? Inside the main method, first instruction is very straightforward. Testing gets displayed in the console. Now focus on the second instruction. Second instruction is what? Obj equal to new b. Okay, so you are creating an object for the class B. Okay, this main thread will do, before creating an object, now it will recognize that there is a dot class file. That dot class file has to be loaded on demand. You are creating an object for class B. So class B, there is no d dot class file in JVM. Okay, d dot class file is there. That is somewhere in the what we call it as in the storage area. Since you are creating an object for the class B, this b dot class file will be loaded inside the JVM on demand, because it is required, because main thread has recognized that the programmer is trying to create an object for a different class, which is B class. Okay, to work with this B class, the b dot class file needs to be loaded. Dot class file is mandatory and it has to get loaded. You are loading it on demand because you are creating an object for class B. So now b dot class file will come into the picture. At the time of loading the b dot class file to the memory or b dot class file to the JVM, static content will be recognized and executed. What is static content? Hey, this is my static block of class B. Okay, now what is the next output? Hey, this is my static content of class B. So what is happening here? At the time of loading the dot class file, if there are any static content, that is getting loaded. And also, if you are getting this in the console, if you are getting the static content in the console, it is also proof that the dot class files are loaded, already loaded in the JVM. You can say in the either way, both are correct. This is a proof. Okay, this execution is a proof that dot class file is loaded inside the JVM. Also, okay, when the dot class files are getting loaded inside the JVM, the static content is getting executed. So don't you think that only if you create an object, only if you depend on another classes, okay, the dot class files are getting loaded. The dot class file is getting loaded on demand. If not, it will not get loaded. Even in your class, you can have, even in your file, you can have any number of classes. There can be class A, okay, class A, and there can be class B, there can be class C, there can be class D, and there can be class E, which has the main method. Okay. Only if you call these classes, only if you create object for these classes, those dot class files will be loaded on demand, or else only the instructions that are in the main method will get executed. That's it. Able to follow. Dot class files are getting loaded on demand. That's why it is called as what? The dynamic programming language. If you go back and see, right, dot class files will be loaded on demand. It will not waste any memory, right? So what is the proof? You want to see the proof? Okay, let me show it for you. Let me show you the sequence of output. This is the code. This is the code. Okay, let me save this. Right? Let me Java compile it. Java C space a dot Java compilation. No errors. Java space A. Now you see, this is my static block of class A. Okay, then testing. Then this is static block of class B. Are we getting the same output or not? Both are same, right? Both are same. This is same. This is same. Execution is justified, right? My explanation is justified, right? What I'm trying to say is very simple. Dot class files are getting loaded on demand. Okay, if you are not creating this object, if you are not creating this object for the class B, okay, then class B would remain in the same place. It will not get loaded inside the JVM. It would remain there itself. The moment you are creating an object, it is getting loaded. What is the proof that it is getting loaded? Because I have deliberately placed the static block so that you will understand that the dot class file is getting loaded. This is the proof that this execution is the proof that the dot class file is getting loaded. That's why the Java is called as a dynamic programming language, because the memory is getting allocated on demand. At the same time, the dot class files are getting loaded on demand. On demand, without the requirement, okay, the files will not get loaded. If the program is dynamic, what is an advantage? There will be no memory usage until and unless you need it, you load it. If it is not required, what is the point of loading it and wasting the memory? Okay, the less memory the program is using, the more performance it is going to have. Dynamic, everything is dynamic in nature here, right? Having said this, so your brains must have been heated up. Okay? So I think we are good for the day. Any questions for me? Do you have any questions?